this question, right, everybody? Complete question. Here matrix given have well mobile silent one. So matrix given have, and here q of xyz is equal to xyz a xyz defined have quadratic form. After that, telling which of the following statements are true. You can see that our given matrix A is not symmetric matrix. So we have to put there and have to make new matrix that is called a quadratic form matrix. Okay, your question like that only last time, madam. So like that question came already. So we can solve direct. If you will start from A, then that everything answer wrong will come. So we have to multiple, have to make new quadratic polynomial, and that quadratic polynomial will give new matrix. That matrix is called a real symmetric matrix, and then we can find whatever options are given here. So we will find So this is our quadratic polynomial. From this quadratic polynomial, again we will write X transpose Bx structure, where B will be the symmetric matrix. So again, either direct I can write, or I will write one time x square. When y square is not there, means missing term, means coefficients will be 0. Okay, so 0 y square z square. This xy means half, we can write xy plus yx, and yz minus zy, and remaining I think xz, that coefficients will be 0. So we can write our matrix x y z. B matrix will be 1 0 1, here 1, here 1, yz means minus 1 0 0. So this is the matrix x y z. So this is our B matrix, and quadratic form can tell, and hereafter whatever they will ask, we will find from this B matrix. Okay. Yeah. No symmetric, no quadratic form matrix, finish. Okay, quadratic form is symmetric, this keep in mind. Yeah, first option later we will discuss. Second option, rank of quadratic form asking. So rank of B find. Suppose we will find elementary transformation, I will do. Rank will be 3 only, R2 minus R1, because next I can make 0 also, triangular form will change. Rank of B equal to 3, so rank of Q equal to 3. When rank of Q equal to 3 means second option is wrong. Signature of quadratic form plus 0 rating. 0 not possible. When our rank 3 have, this meaning determinant is 0. This meaning all eigenvalues are non-zero. Non-zero means maybe all are positive. Our signature what will have? A signature of Q, possible signature. Plus plus plus, plus plus minus, plus minus minus, like that. Minus minus minus, maybe all are possibilities writing. By trace and all we can find also, maybe all are not minus, because trace will be 0, 1, 2, 3, 4, anything maybe, then mixing will come. So these are possibilities. So what we will do? Third option also wrong. D option, signature of Q takes the value 0 for some non-zero vector x. Here you see, theoretic quadratic form Q takes the value 0, means Q will be 0 for some non-zero vector x, y, z. So you have to think x, y, z any value, and have to put in Q of x, y, z, and have to see that will be 0 for or not. This is Q of x, y, z. You think what x, y, z non-zero value I will put, this will be 0. Zero 1 0, x 0, y 1, z 0. 2xy have, so x 0 means 2xy will be 0. 2yz have, z is equal to 0 means 2yz also will be 0, and z square 0, x square 0. So like that you have to think any number. This is not only one number. I can put x plus 0 1 0. So 0 1 0 will be 0. Correct. Like that, and for some is at least one non-zero vector also 0 coming, means true option. Correct. And this is quadratic polynomial, either single variable or double variable. This is confirm have any x, y, z value must will give 0, any non-zero value. Any polynomial, normal polynomial, that is any x, y, z I can put, and 0 I can make it. How this is possible? Never will come 0. So if you can't find x, y, z value also, you can take out. D must be true. Understanding? First option given have matrix of second order of partial derivatives of the quadratic form Q is 2a. When we have function of several variable, no, this is now function Q of x, y, z is a function of n unknowns. When we have function of several variable, that time single means first order partial derivative is called a Jacobian. Any function given have f of x, y, z or more than any, at least two variables. And if you want to find partial derivative of that function and all, then partial derivative in the form of matrix, that is called a Jacobian. And second order partial derivative is called a, no, Wronskian we have to use for single function. That is also single variable functions are linearly independent, dependent. For that Wronskian we have to use. Several variable have means first order partial derivative means Jacobian, second order partial derivative means Hessian matrix. Okay, so Hessian matrix can tell this is completely out of syllabus. One time they asked, after that not asking also. And I saw research paper and all. If research paper is starting from Hessian matrix, linear algebra and all. So what is Hessian matrix? Just I will tell, and we can proceed without writing also, because Hessian matrix always will be symmetric matrix. Always. So first Hessian, what is Hessian matrix? See. This is the Hessian matrix, and Hessian matrix is always, if real coefficient is real symmetric, complex means complex symmetric, but this will be the always symmetric matrix. Okay. So this concept they are asking here, you know, without writing this matrix we can find. Hereafter you see here Q of x, y, z, this Q of x, y, z is three unknowns variables. So Hessian matrix will come 3 cross 3 matrix, x, y, z. So you can write h of q box x is equal to del square f by del x square, f means q, del square q by del x square, del square q by del x del y, del square q by del x del z. Again del square q by del y square, del square q by del del square q by del y del x, del square q by del y square, del square q by del y del z. Third row will come del square q by del z del x, del square z by del z del y, del square z by del z square. And from q you can find whatever partial derivatives have, and you can put that matrix will be symmetric matrix. But this much also no need. You see, writing Hessian matrix will be the symmetric matrix, correct? Here you see matrix of second order partial derivative of q. This meaning Hessian matrix. Hessian matrix is equal to 2a. Yes. and Hessian matrix must be symmetric. H is here given have H is equal to 2A, but Hessian matrix must be symmetric. But you see our A matrix, this is a symmetric? No. So 2A how will be symmetric? So first option runs wrong. H will come 2B. B is symmetric, no there. This H if you will find, no, Q, partial derivative Hessian matrix of Q, H of our quadratic form Q box X, if you will find, 2B will come, not 2A. Let her try. Huh? What true? Yeah, that will be the Hessian matrix always symmetric. 2B don't write, that is depend on this matrix, 2B will come. Hessian matrix always symmetric, either any type of quadratic form. This is general I gave, any type of function of x, y, z or x function of n tuples, that Hessian matrix will be symmetric. Right everybody? Question complete have? So on answer only D option will be true. Right from here. A JAM student both are integral class doing, no? Both are. No problem? You sit here, that chair take. Sit here. You come, I will take cover. What reading, everybody? Real. Notes revision.
Sir, I prepared that gate is working or not.
Later we'll see.
Afternoon we will take Xerox.
Show me. You write here must first that street dogs are sitting in steps. Any place, right? Then what? Otherwise, who will know? Why telling? Again, will not write must dog. Dogs are coming and sitting in steps. Street dog. This type, right? And yesterday late, everybody came. You came yesterday, not coming.
I asked permission from going to college.
Okay, yeah. You also came, but everybody late came yesterday. That matrix completed, this matrix. This question, right, everybody?